Hi friends, today we'll solve a problem. Problem name is trapping rainwater. The problem number is 42. It is a Leetcode problem. So what the problem is saying, given in non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. Okay, so here's the input is given of the each bar height, and after rainwater we need to calculate that how much water can trap. So here we can see that answer is giving 6 unit. Now we need to explain that how it is working. Okay, so here the list of the bars height. This bar is 1, this bar is 0. So it started from here 0 1 0 2 1 0 1 3 2 1 2 1. So from here we can see that here maximum 1 unit of water can store, because the property of the water is going downside. So as the maximum support it can get from the left side, so it can store here from this side, or both from the both side. The support it can get is 1 unit, so 1 unit is stored. Here also 1 unit, here 2 unit, and here 1 unit, and here also 1 unit. So 1 1 2 to 4 5 and 6. Now how it happens, see, whenever we will store in any water, from this diagram we can infer that the minimum of the maximum support it can get from the both the side minus the height of the bar, right? See here, the maximum support it can get from left side is 1, from right side is 3, that maximum support. Okay, but we have to take the minimum of that 1, and then it is 1. Why? Because this water cannot but if it is goes to this way, it will not get, means let's fill this one and this one, it will not get any support from here, right? It will fall back. So maintain the equilibrium, water will be stored like that. It will check the minimum of the maximum support from the both the sides. It will take. Means what I mean to say is, water at any bar will be equals to minimum of max of left side bar, comma max of right side bar, minus height of the bar, height of the bar. We are getting this formula by seeing these diagrams. See, water at any bar, see water this one, maximum of left side bar is 1, right? Maximum of right side bar is 3, minimum of 1 and 3 is 1, and height of the bar is 0, so 1. Similarly here, maximum of left side bar is 1, maximum of right side bar is 3, so minimum of this 2 is 2, so here it is maximum getting 2, and height of the bar is 1, 2 minus 1 1. Here maximum from left side is 2, maximum from right side is 3, minimum of that 2 is, means left side maxima, right side maxima is 2, and height of the bar is 0, so 2. And here the left side maxima is 2, right side maxima is 3, so minimum of this 2 is 2, so 2 minus 1 is 1. Now here we are getting left side maxima is 3 and right side maxima is 2. Minimum of this 2 is this one minus height of the bar, that is this one, 2 minus 1, 1. So now we will code it. We will solve using two pointer approach. One is variable I equals to 0 and variable j that will be start from this, means I start from left side, j starts from the right side. Height dot count minus 1. Okay, now we will take a variable that answer is equal to 0. Now we will take two variable left max equal to 0 and variable right max 0. What these two variable will do, they will keep a track of the left side maxima and the right side maxima. And here, as the array is non-negative, so we can first consider them as their minimum value is 0, because we are initiating this. So we are taking their minimum value 0, 0. Then we will, by comparing, we will calculate their maximum value. Okay. So now this left max is 0 and right max is also 0. Okay. Now I will run a while loop that will run from I and less than j. Okay. Now first I will calculate the left max. Left max will be max of left max comma height of ith bar. Let right max will be max of, sorry, this is already you have defined, so no need to write let, is equal to right max and height of that, we are calculating for the right side, right? So the height of the jth bar, means this I will keep track of the maximum, we will traverse from this side to this side, j will traverse from this side to this side. So this I will used to calculate the left max at any given index, j will use to calculate the right max from any given index. Okay. So now if left max is less than right max, as we said that we need to calculate the minimum, so the support is from the left side. Okay, so in that case my answer will be updated as left max minus height of I, means left max on that position. Okay, that what is the maximum value from the left side. If the minimum of this left max and right, and we have to take the minimum of left max and right max. So if left max is less than right max, so you have to take the left max minus the height of the bar, that we have explained earlier why it is. Then we will increase the pointer. Else means if my right max is greater than left max or equal to, then we will calculate this one as right max and height is jth, because j is keep tracking from the right side. Okay, and we will decrement this pointer j minus equal to 1. So like that, see, we are calculating the left max and right max on the go, and we are checking which one is minimum and then calculating the how much water is stored on that particular bar. Okay, then when it is complete, then we can return the answer, right? Okay, so let max maximum height I, right max maximum height j equal to height I. Okay, now let me to run this. Let me check that how it is working. Yeah, it is accepted. Now I will submit this. Yeah, this is also accepted. Okay, so here the time complexity now will calculate. Time complexity will be order of n, because we are iterating all the elements of the array, and the space complexity will be on, means constant space, because we have not taken any extra array or something. So space complexity also order of n. Okay, so I think its problem is completed, and if you means feels that I'm able to explain this concept to you and it's helpful for your interview, next interview, then please like this video, and if you want to get this kind of videos in future as well, please subscribe my channel. Thank you.